Well, hello there, AP Physics. It's time to do some problems, and I'm just very excited to do them with you. So, let's find the position of the object with the following values of t. Now, really, this is some calculator work, right? X is 3 times 1 to the 4th plus 1 squared plus 1 cubed. Are you kidding me? 3 plus 1 plus 1, 5 meters. Oh, so silly. And we just continue this, so 3 times 2 to the 4th plus 2 squared plus 2 cubed. Can you imagine? That's like 3 times 16 plus 4 plus 8, which ends up being 48 plus 12. I'm getting 60 meters there. Don't forget your units. They like those on the AP. And then for C, gosh, it's just getting crazy. 3 times 81 plus 9 plus 27. Are you kidding me? So that's 243 plus 27 plus 9. And that's going to get me, let's see, 270 plus 9. I'm getting 279 meters. I think that's right. Yep. And then for D, it just doesn't stop. Wow. 3 times, let's see, wow. So 16 times 16, I think that's 256. Let me check that out. It is plus t squared, which is 16, plus t cubed, which is 64. So we're going to end up getting, let's see, 768 plus 80, which ends up being 848 meters. I'm actually glad that I worked this out for you, even though you don't need a solution necessarily because it's plugging it into your calculator. I want to challenge you to redo this problem the way I've done it here without using a calculator. That would be a really good idea for the AP because on multiple choice you're not allowed calculators, young ones, and this is the kind of level of work that they want. Now, the displacement between 0 and 4 seconds, that's part E. So that's going to be x at 4 minus x at 0, which is going to simply be 848 minus 0, which is 848 meters. Now, the average velocity for the interval 2 to 4 seconds, let's be clear, the average velocity is going to be x at 4 minus x at 2 over 4 minus 2. It's like you use a rise over run formula for your position graph, regardless of its shape. You just take 2 points, and you get the slope of what's called the secant line. So if I have a graph like this, let me just remind you, it's right, so here's a graph, and what we're kind of doing is we're looking at x at 4 and x at 2, and we're getting the slope of this line here. It's like x at 4, x at 2, and this is like 2 seconds, and that's 4 seconds, and it's the slope of the secant line. And so when we actually plug this in, use our numbers, it's going to end up being 848 minus 60 over 2, which ends up being 788. Yeah, 788 divided by 2. When we plug that into our calculator, that's going to be 394 meters per second, if I have that right. So not surprising, it's moving pretty quick. So that is, in fact, the answer to question F. It turns out this little drawing that I did here of the slope of the secant line is, in fact, the answer to part G. So that's something we hadn't considered. And what you're going to be learning in calculus is if I really want the speed just at 4 seconds, how do we get the slope of that tangent line, which you may recall is from pre-cal, it's called the derivative. You're going to be working with that very closely. And so we'll be getting into that a little bit later in the quarter when I feel comfortable that Not just calculus BC, but also calculus AB feels that they have some good grounding in that material. So that's the first problem for the homework.